All right, guys, I want to wrap up 7172 so you guys are aware of what is going on. Okay, so look, here is a fundamental trig identity sheet that I think I'm going to give you guys. It's the same thing as the pink, the one that I've highlighted in pink. The only thing that's different is these are the three main Pythagorean identities. And what this sheet has done has rearranged them. So like, do you see how cosine sine equals 1? It rearranged it so it shows you that sine squared is 1 minus cosine, and then cosine is 1 minus sine. And then it shows you, so you don't even have to really, I don't want to say you don't have to think, but like it's just easier for you to reference for when you see identities that match. It's just make it a little, yeah, it'll make it a little quicker for you, I think. You will also get these identities. Notice these are the same sum of difference identities that we had in our notes, but instead of U and V, the letters use are A and B. But it's the same thing. It's just two different angles. The first angle is A or S or whatever they use, and then the second angle is B or T or whatever it is, U and V. You will get the unit circle. So it's in your best interest, guys, to screenshot this stuff, put it right next to your problems so you get into the flow of doing things, all right? Through these examples, it's just a review of, oh, this is how we simplify. Oh, this is how we verify, and then the sum of different stuff.
Wait, where'd you get that?
7.1, 7.2 practice.
Are we gonna have modules?
It's in modules. No, I'm just going over it. It'll be a review, like a video, so you can watch it this weekend. All right, so if we're going to simplify, that just means, hey, I want to make smaller. All right, think about our most basic trig functions. What are the two most basic trig functions? Sine and cosine. So we're always trying, our goal is to get to sine and cosine. So when I look at this, I see a trig function that is squared and attached to a plus or minus 1. So where should your eyes go on your trig identity sheet? To the Pythagoreans. Is 1 minus cosine squared on that Pythagorean identity sheet? Yes. What is 1 minus cosine squared the same as? Sine squared. So I'm going to replace that with sine squared theta, and I'm going to leave it over cosine squared theta. All right, that's pretty simple right there, but I can simplify that even more. I can change sine squared and cosine squared into what? What's sine squared over cosine squared the same as? Tangent squared. There you go. Now, at different times within the problem, if you see something that you would simplify, it's fine. It does not matter where you do the simplifying. It just matters that at the end, you have the simplified answer. Some people like to simplify within the problem. Some people like to wait to the end. It doesn't matter. Let's look at number 2. Why is this problem super simple? What is there a lack of? What is there not in here? There's no addition and subtraction. And there's nothing what? There's nothing squared. This is just all multiplication. So when you have just all multiplication, let's just go right to sines and cosines. It's the easiest. So my numerator is going to be cosine x over 1. And then secant is the same as what? 1 over cosine. Okay, perfect. And then what can I do with cotangent? What's cotangent the same as? Cosine over sine. Perfect. So let's start the cross-out party. What can you cross out in the numerator? Cosine here leaves me with what number? 1. Over cosine sine. I have 1 divided by a fraction. What do? You keep. Good job, guys. Change. Flip. What is sine over cosine the same as? Perfect. Good job. All right, let's look at 3. 3 gets a touch harder. Again, we're not verifying yet. We are not verifying yet. We're just simplifying. We're making smaller. So if I look here, God bless you, I see 2 things that are concerning in the numerator. What's concerning? The what? The minus, agreed. And what else do you see? Squared. Do you see something squared that's attached to a plus or a minus 1? No. Okay, so we can't use our identities yet. But what do you notice, God bless you, about the numerator?
You can take a cosine.
They both have a cosine, don't they? Can I divide out a cosine from both of these? If I take out a cosine here and a cosine here, in my numerator, I take out the cosine. It doesn't go anywhere. I just bring it out in front. So I'm left with secant squared whoops, forgot the C. Secant squared minus what number? 1. Anything divided by itself is 1. Very good. And then I have secant squared on the bottom. Now, can you just cross out those secants and be like, oh, good thing? No, because it's attached to a 1. But we've uncovered an identity. Look at your identity sheet. What is secant squared minus 1 the same as? Tangent squared. So I have cosine out here. I have tangent squared here. And then I have secant squared on the bottom. Now, at this point, guys, we have all what left over? All multiplication. What did we do in our first problem when we had all multiplication? We changed everything to what? Sines and cosines. Let's just go ahead and do that. As soon as you get to all multiplication, just go to sines and cosines. So in your numerator, you have cosine theta over 1. What's tangent squared going to become? Sine squared over cosine squared. And then what does secant squared become? 1 over cosine squared. All right, I see lots of sines and cosines and blah, 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 right? Now, if you want to simplify within the numerator, you absolutely can. Is there something we can cross out? Okay, I can cross off this cosine, and then it leaves with just 1 here, correct? So now I have a fraction divided by a fraction. Keep, change, flip. So I have sine squared over cosine times cosine squared over 1, right? Okay. Now what happens? I can cross off a cosine here and then 1 here. So I'm left with sine squared theta times cosine theta. Is there anything else I can do here? No. That is as simplified as you can go. Some people are like, how do you know that? Well, let's go through the list. Do you see a trig function squared that's attached to a plus or minus 1? No. Do you see any plus or minuses anywhere? No. Do you see any fractions? No. What are the 2 most basic trig functions? Sine and cosine. That's it. That's all you can do. All right? Some people ask, are you going to have one like that? Guys, I cannot replicate exactly what is going to be on the test. Every single one of these is a little different. So I'm working through different kinds of problems to get you guys to see different kinds of things. You'll start to see patterns. You start to see repetition of how to solve, but they're not all going to be exactly the same. All right, let's look at this next one. How is this one a little bit different? I try to do stuff a little bit different for each of these. I see an addition sign, okay? Now, you could, if you wanted to, right away just go all sines and cosines. God bless you. If you wanted to, and then simplify that way. I like to look at this and say, okay, there's nothing squared that's attached to a plus or minus 1, so it's not an identity. But I do see a plus sign. When there is a plus sign here, what can you do with this denominator?
Separate.
You can separate. I'm going to sneeze. When I separate this, I can write this as tangent x over tangent x plus cotangent x over tangent x. Can't I? If you add fractions, the denominator stays the same. So you're fine there. You can do that. Now, if you want to simplify this way, perfect. What is tangent divided by tangent? 1. Plus, what can I do with cotangents and tangents? What is cotangent in the numerator? Cosine over sine. And then what is tangent? Sine over cosine. Right? Okay. Now that looks like we made it more complicated, doesn't it? I still have my 1 hanging out here. How can I simplify this? Keep, change, flip. Do you see how we keep doing the same thing? So cosine x, sine x. I'm going to change this and I'm going to flip it. And it's going to become cosine x over sine x, right? Yeah. So this just leaves me with cosine times cosine is cosine squared over sine squared. All right. Well, how did that really help us?
Cosine over sine is cotangent.
It is. But that's just going to take us to where we started.
1 plus cotangent squared x.
Okay, you could do that. All right, I see two different ways. Look, I'm going to go what Marcel and Marissa just said. What is cosine squared over sine squared the same as? Look, we're going to go on two different paths here so you guys can see.
Cosine squared x.
Cosine squared over sine squared is the same as 1 plus cotangent squared, right? Look at your Pythagorean identities. What's 1 plus cotangent squared the same as? Cosecant squared, all right? That's totally fine. That is the answer we're looking for. Last period, I did it a different way. And I was right here, and I said, guys, okay, if we're always going to go in the path of sines to cosines, if I add 1 plus cosine squared over sine squared, how do I add those two together? What do I need?
Same denominator.
I need a common denominator. What's my common denominator going to be here? Sine squared, right? So this fraction would need a sine squared on the bottom, so I would put one where? On the top, okay. So I have sine squared. Plus, does the cosine squared need the sine squared? No, it's already there. What do you guys notice about the numerator? What's sine squared plus cosine squared? It's just the big number 1 over sine squared. Okay, well, what's 1 over sine squared the same as? Cosecant squared. Did we get the exact same answer? Yes. Go ahead. You can go next. You got the exact same answer with two totally different trains of thought. Is that okay? It's absolutely okay. It's good that we see things differently, guys. As long as mathematically, if Marcel and Marissa showed me this step, they would get full credit for that. If you went this way, you'd get full credit. As long as it makes mathematical sense, it's totally fine. You just have to have some logic behind it. You got to show me your thinking. All right, let's go to verifying. Verifying to me is a little easier because it kind of gives you a roadmap. You see where you're starting and you see where you're trying to get to. Obviously, guys, which side looks harder? The left, okay? Now, this is actually quite an easy problem because there's nothing squared. There's nothing attached to a plus or minus 1. There's no fractions, right? The only thing we have here is multiplication. When all we have is multiplication, what's the easiest thing we can do? Turn everything into sine and cosine. So tangent is sine over cosine. Cosecant is 1 over sine, correct? And then cosine would just be cosine over 1. Now, when you're multiplying, it doesn't matter if the numerators and denominators are right next to each other or if they're a couple fractions away. If something in the top and something in the bottom is exactly the same, what can you do? So look, sine crosses out with sine, cosine with cosine. What are you left with? 1 equals 1. Literally that easy. All right, let's go over here. Woo! Super. This one's hard. Not hard, it's just different. All right, which side looks more difficult? The right. How come? Because there's a minus, right? The one on the left is just multiplication, so whatever. But the one on the right looks a little more difficult. If you wanted to simplify the one on the left to kind of give yourself a little pathway, that's fine. You could do that. All right, think about this. I could change tangent into sine over cosine, right? And I'm timesing this by sine squared. You guys agree? Okay, I just giving you a look. So now I look and I say, okay, is there anything squared? Yes. Is it attached to a plus or minus 1? No. So I can't just create an identity here. I'm subtracting. So let's go ahead and simplify this. I'm going to say this is sine over cosine, sine squared over cosine squared, minus sine squared over what? 1. All right, guys, this is the same kind of problem. I'm subtracting fractions. You have to have a what? A common denominator. My common denominator would be cosine squared, right? Well, sine squared doesn't need it over here. Minus, what do I have to multiply the bottom by here? Cosine squared? So then I have to multiply the top by what? Okay, so all right, did that really help us? I know it appears like it didn't, but it did. What do you notice about the numerator? You can take out a sine squared. If I divide out a sine squared here, sine divided by sine is going to give me 1 minus cosine squared over cosine squared. Oh, good. Can I just go ahead and cross off the cosines? No. But what, guys, on your Pythagorean identity sheet, can you tell me 1 minus cosine is the same as? Sine squared. Does it look similar? Exact same thing. What does this say? Sine times sine. So sine times sine. That's the same thing I have there. And then over cosine and, yeah, it's the exact same thing. If you guys did not simplify the left-hand side, sometimes it's good to just kind of give yourself an idea. But if you didn't, if you got here, you're like, now what? Okay, guys, we're left with just multiplication, right? So I would tell you to just turn everything to sine and cosine and then try and cancel. Well, we've already done that. When we had a problem, like up here, that had one denominator and a plus sign, what did we do? We split it up, right? And we put it over the same denominator. Because when you add denominators, when you add fractions, denominators stay the same. You can split up multiplication as well. But the process is a little different. If I was going to split this up, I would say sine squared theta over cosine squared theta times sine squared theta over 1. Why did I put it over 1? Why didn't I put it over cosine squared? Because it's multiplication. When you multiply, guys, if I multiplied cosine squared times cosine squared, I'd get cosine to the 4th. When you have a problem that there's all multiplication, you want to split it up, just put the denominator with one of the numerators. Then the other one gets a 1 underneath it. If there's a plus sign, they both get the same one because the denominator stays the same. But multiplying, you just stick the denominator with 1. Now, guys, what is sine over cosine the same as? Tangent, right? Squared times sine squared, which is what we started off with. Right? That's a tough problem. That takes a little bit of thinking. I understand that. But sometimes if you pick the side that's the hardest, okay, good. If you go, okay, wait, let me just look at the other side just to kind of help myself. Give me some guidance on where I'm going. Sometimes that's helpful. But always try something. When in doubt, change everything to what? Sine and cosine. All right? This problem's going to be similar. Which side obviously looks harder? This is your answer. Okay. The meat inside. Which side is obviously more difficult? The left side. Why do you think the left side's harder? Because there's a denominator and it has a minus sign. It's not squared though. So let's create an identity. The first thing we do when we see a denominator that has a plus or a minus 1 and it's not squared is we multiply by the conjugate. What's the opposite or conjugate of 1 minus cosine? 1 plus. Okay, guys, that's an alpha. If you want to just change it to an x, change it to an x. I don't care. If you want to do every problem with an x or a theta, that's fine. So in the numerator, I'm just going to leave sine hanging out here. And then I have my 1 plus cosine. Now look, guys, what are you trying to get to over there? 1 plus cosine, right? All right, so we're on the right track. That makes us feel better that we're on the right track. So on the bottom, let's multiply. What's 1 times 1? 1. What's 1 times negative cosine? Negative cosine. What's cosine times 1? Positive cosine. And then what's cosine times negative cosine? Negative cosine squared. Good. All right, hopefully you're starting to see some repetition here. What happens in the middle? So you're left with 1 minus cosine squared, which is the same as, look at your Pythagorean identities. What's 1 minus cosine squared same as? Sine squared. Whoops. I was going to make it a theta. All right. Anything? Cancel what?
Sine.
Cancel a sine. So this is a 1, right? And this is here. So I'm trying to get to that, though. Can I separate?
Yeah.
Can you? Whoa.
Yeah. You can.
I can, right? There's a 1. And so I can say 1 over sine theta times 1 plus, alpha, whatever the letter that is. What is 1 over sine the same as? Cosecant. Which is now, guys, we have the same thing. Now, somebody asked, will you please give partial credit? Of course. Every step that you give right, I want to give you points for this. I understand that this stuff is difficult. I understand that. I'm proud of you guys for as much as you are trying. For the most of you that are. I appreciate it because this is not easy. I know that. All right, let's scoot along. I'm going to do one of these at the top because they're both pretty much the same. And then we'll do the bottom ones. But when you're given an angle that is not on the unit circle, this is where we say, oh, geez, I need 2 numbers that add up to or subtract to give me one of these. So which one do you guys want to do? Sine or cosine? Doesn't matter.
Sine.
Okay, let's do sine. What 2 numbers are going to add up or subtract to give me 285?
240 and 45.
All right. I hear 240 plus 45. Does it have to be those 2 angles? No. You do whatever you want, as long as it's on the unit circle and it equals the angle you're looking for. So this is going to be my S, my U, my V, whatever the first angle is in the formula. Let's call it, what are these letters in here? U and V? Okay, so this is my U, and this is V. All right, what's the ordered pair at 240? Okay, what is the ordered pair at 45? Root 2 over 2? Okay, so go a little further and tell yourself, okay, the first is my cosine, the second is my sine, right? Now you guys are literally picking the formula. Which formula says when I add 2 angles together, I find the sine? It goes sine, cosine, cosine, sine, right? I'm going to write it out. Sine U times cosine V plus cosine U sine V, correct? Mm-hmm. You guys are going to have those formulas on your paper. Go ahead and go. You'll have the formulas on your paper. You'll have a paper with it. So just go ahead. Now we fill in. What is the sine of U? Negative square root of 3 over 2. What is the cosine of V? Square root of 2 over 2. Good. Plus, what is the cosine of U? Negative 1/2. And what is the sine of V? Perfect. And now we simplify. A house times a house just gives us a bigger. So negative root 6 over 2 times 2 is 4. Plus, what is negative 1 times square root of 2? Negative root 2 over what? 4. Can I combine these two? How? Negative square root of 6 minus the square root of 2 over 4. That is it. You cannot say that negative square root of 6 minus 2 is negative square root of 4. That is not the case. Those are 2 different radicals. So you just leave it just like that. Now you can use those same 2 angles, 240 and 45, and use the cosine formula. You can use a different set of angles. It does not matter. Oh, my nose is so itchy. All right. We're doing good. We're doing good. All right, this last bit I'm going to talk to you guys about. This is that one where we're working backwards. You're going to write each expression as sine, cosine, or tangent, and then find the exact value. So we're going backwards. The first angle is your A, your U, whatever it is in the formula. The second angle is the second one. But which formula matches sine, cosine, minus cosine, sine? Which formula is that? Sine, cosine, minus cosine, sine. Sine of what? Sine U minus V. We're working backwards. So U is the first angle. So it's the sine of 210 minus the second angle, which is 150. Guys, what is 210 minus 150? So sine 60. Is 60 degrees on the unit circle? Yes. So that's the first part of your answer. You have written this formula as one single trig function. Now you identify what is the ordered pair at 60? 1/2, comma, square root 3 over 2. This is my cosine. This is my sine. So what is the sine of 60? Square root of 3 over 2. Everything that I have in that box is your answer. You write it as one single trig function. That's part of your answer. And then the exact value, square root of 3 over 2, is your other part. All right, so look at 2. Obviously, guys, what formula are we talking about? Tangent, because it says tan, 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 tan. Which tangent formula is it? It's tangent of what? U plus V. So it's tangent of what's 300 plus 30 is what? Tangent 330. Is 330 on the unit circle? It sure is. So that's the first part of your answer. Good. And then how do you find the tangent of 330? Well, what's the ordered pair at 330? Square root of 3 over 2. And negative 1/2. Now, somebody last period said tangent is y over x. I agree. This is my x. This is my y. So tangent is y over x, correct? Somebody else said, well, isn't it cosine over sine?
No, sorry.
No, I meant sine over cosine. Sorry. Sine over cosine? Isn't that the same thing as y over x?
Yeah.
Both ways is fine. But you're going to do a little algebra here. You're going to say, okay, I have negative 1/2 divided by square root of 3 over 2. So I have negative 1/2 times 2 over the square root of 3. What happens with your 2's? They cancel. So I have negative 1 over the square root of 3. That's no bueno. Multiply by the square root of 3. So I have negative square root of 3 over what? 3. So your answer here is both parts. The tangent of 330 equals negative root 3 over 3. Yeah?
Yep.
All right, last one. Which formula says cosine, cosine minus sine, sine?
The adding one. Cosine.
Cosine, which one?
U plus V.
Cosine of the adding one. I like that, guys. Be careful. Cosine's that tricky one. If inside the formula they're subtracting, then it's the cosine formula that adds the two angles together. So when I say cosine of 100 plus 50, it's the same as the cosine of 150. Is 150 degrees on the unit circle?
Yes.
Sure is. What is the ordered pair at 150?
Negative square root 3 over 2, 1/2.
This is my cosine. This is my sine. So what's the answer? What is the cosine of 150? Negative square root of 3 over 2. The whole thing in the box is your answer. Writing as one single trig function and then telling me the ordered pair there.
For this kind of problem, are you only going to give us answers that are on the unit circle?
Yep. Yes, when you get to this point here, when you condense it, it will be on the unit circle. If it's not, then you use the wrong formula. Yep. Questions? Okay, I will upload this video momentarily, and then we're going to do solving next week.